In this video, we're going to be talking about solubility. And solubility is how well something dissolves or whether it will dissolve or not. Usually when we do solubility, we express it in grams of solute dissolved in grams of solvent. So how well they dissolve. Now we're going to talk about three words. The first one is it's called unsaturated. So let's say I'm making a solution of some sugar water. So I've got some water here. I've got a glass of water. I dump some sugar in it. I put just a little bit of sugar in here and it all dissolves in the water. Okay, that's what we would call unsaturated. So in other words, it can hold more solute. And the solute would be the sugar and the water would be the solvent. So we can actually add more. If we just add a little bit to it, we can add more to it. All right. If something is saturated. So sometimes we say if I was out in the rain and it poured on me and my clothes are saturated with water, that means they're clear full of water and they can't hold any more. So how does this apply to a solution? So if I'm adding some sugar to my water, I add a little bit and I stir it up and I add some more and I keep stirring it up and I keep stirring it up. Well, I eventually get to a point where the water holds all the sugar that it can and I can't put any more in it. If I put any more in it, it's not going to dissolve, and that's what we would call saturated. So in other words, it holds all the solute it can. Okay, and we can't put any more into it. All right, so that's what's called saturated. Now, the next one is what we call supersaturated. So here's what I do. So if I want to make some homemade syrup, I want to put a lot of sugar in it. So what I'm going to do with my homemade syrup, I'm going to heat it up. So I'm going to heat up the water. So here I've got some water right here. And then I'm going to add some sugar in it. And when you heat up water, you can put a lot of sugar in water. You can put actually about double or triple the amount of sugar in water. So I put all this water in here, and let's say I've got it boiling. It's at 100 degrees Celsius. It's boiling, and then I let it cool down. So now I let it cool down to room temperature, 22 degrees Celsius. And my water is full of sugar, but the sugar does not fall out of the solution. It actually stays in there. Well, normally I shouldn't be able to put that much sugar in there, but if I heat it up, put a lot in, and then cool it back down, and it holds more than it should at that temperature, that's what's called supersaturated. So it holds more solute than normal at a specific temperature. Okay, and that's what's called supersaturated, when we have a solution that is supersaturated. So let's do some problems with solubility. This is going to be page 368. I'm going to do example problem. This is 12.2. He gives us two things. It says here at 20 degrees Celsius, the solubility of potassium chloride is, so we could put 34 grams of potassium chloride in 100 grams of water. That's how much it will dissolve. In the laboratory, it says a student mixes, so a student's going to try and mix 75 grams of KCl in 200 grams of water. Okay, now our question is it going to fit? Well, if we just look at this, if we go 34 times 2 is 68, so we can only put 68 in 200. Well, we want to put 75, so no, it's not going to fit. But let's go ahead and do this, figure it out. So let's start with 200 grams of water. So we have 200 grams of water. We're just going to do a conversion. Here's our conversion factor we're going to use right here. We're going to say for every 100 grams of water, we can mix in 34 grams of KCl. So 200 times 34 divided by 100 equals 68 grams of KCl. So that's all 200 grams of water can hold. can only hold 68 grams. Okay, so that's how much will dissolve. It says, is the solution saturated or unsaturated? So if we got 75 grams and we can dissolve, it's going to be saturated because we can dissolve all that. And then it says, what is the mass in grams of any solid KCl left undissolved in the bottom of the container? So what's going to happen is when we mix this in here, we're going to put all this potassium chloride in here, and then there's going to be some left. Well, how much is left in the bottom? Well, I can only hold 68 and there's 75, so we're going to go 75 grams minus 68 grams equals what's left in the bottom. Oops, that's supposed to be an 8. So there's going to be 7 grams left in the bottom, all right? And so we can figure out the solubility of those that way right there. Okay, the next thing we're going to do is we want to talk about how temperature affects solubility, all right? So we're going to do temperature. So how does temperature affect solubility? Well, we talked about it in right up here with dissolving our water and our sugar right here. So usually, not always, but usually when you raise the temperature, you can dissolve more solute. So usually more solute can be dissolved at a higher temperature. At a higher temperature. That's not always true, but usually that's how it affects it, that as a higher temperature, you can put more solute in there. Okay, next thing we're going to talk about is how do we know whether something is soluble or insoluble in water? Okay, so for this one, I'm going to actually bring up a chart, and this chart is on page 370. Let me paste it here, move it around, and this we're just going to move it right over here. So here are some solubility rules, so we can tell whether something will dissolve or not. Now, if you remember, I actually gave you a solubility chart. It was a whole list where you would match them up and see where it said it was soluble, insoluble. We talked about precipitates, and this is when we were doing double displacement reactions to see what was a precipitate, and I gave you a whole chart on that, but this is just kind of a short one here. It tells you solubility rules, all right? So let's go ahead and go through it. It says solubility rules. Got to get my pen back. So solubility rules right here for if I have a positive ion. If I have a positive ion that has lithium, sodium, potassium, rubidium, cesium, or ammonium in it, all those are going to be soluble in water. Okay, so if I have lithium chloride, it's going to be soluble. Or if I have sodium hydroxide, it's going to be, as long as it has that ion right there in it, then one of those ions that's going to be soluble for sure. All right, negative ions. All these negative ions, so nitrate and down right there is the acetate, those are going to be soluble in water. That means they're going to dissolve. Okay, if they have a negative ion, well, let's go back to this one. So examples of this one right here is ammonium nitrate. So it's going to be soluble. All right, a chlorine or bromine, except when it contains silver, lead, or mercury. Okay, so just like salt. So salt is sodium chloride, has a chloride ion. It's not one of those. It will be soluble. But if we come down to silver chloride, it is not very soluble in water right there. Okay, so because of that one right there. All right, so the next one is SO4, except when combined with those. So all we're going to do is we're going to look at our ionic compound and say, okay, which one of these does it have? Is it soluble or not, or insoluble in water right here? So there's a few of them. Let's look at some of them on this. This is some problems on page 371. Just gives us some examples. We're going to compare them right there. The first one is sodium phosphate. So we look, okay, is it soluble or insoluble in water? Well, it has a sodium ion. So if it has a sodium ion, it is soluble in water for sure. The next one is we have calcium carbonate, which is chalk, but calcium carbonate right there. You look, there's no calcium and there's no carbonate up there, and so this one is going to be insoluble in water. It will not dissolve in water right there. Okay, so we just have to look up there and decide whether they're soluble, insoluble, just by looking on this chart right here of what it is. Okay, and that will tell us the solubility of it.